Okay, so now let's construct a circuit that looks like this. We have a voltage here of V naught, and here we break up the path such that there is a resistor with resistance R naught there, but there's a lower path where we break them up into a resistance R naught here and R naught here. So resistors in parallel. Actually, let's put another resistor there of resistance R naught. And let's then come back around to here. And that's our circuit. Okay, so let's first find the equivalent resistance of the circuit. So we have a little piece here where the resistors are in parallel, and we can think of one overall resistance satisfying 1 over R, being the equivalent resistance of this part, satisfying 1 over R naught plus 1 over R naught, which is 2 over R naught. So we've seen this kind of thing before, so the equivalent resistance R of that part is half of R naught. So we can think of this part as having resistance R naught. I won't make the rest of the circuit. Resistor with resistance R naught here, and a net resistor with resistance R naught over 2 there. Well, let's just make the rest of the circuit. So that's what it looks like. Okay, so now we can reduce this further to, right, there's a current here that goes through both of these in series. And so we have an equivalent resistance here, which is just the sum of these two. And so that's 3 R naught over 2 for this piece. And then we have this one and this one that are in parallel. So we have an overall resistance for the circuit, 1 over R equivalent, which is equal to 1 over this, which is 2 over 3 R naught, plus 1 over this, which looks like that. And that's equal to 5 over 3 R naught. And so we have an equivalent resistance for the circuit, which is the inverse of that, which is 3/5 R naught. And so we can get a net, we can get the current in the circuit. So the current going through here, let's call it I total, right? I total, if this is an ohmic circuit, then I total obeys Ohm's law. V equals I R, so it's V over R equivalent. And that is V naught over 3 R naught over 5, which looks like that. So that's the total current, and then we can find the current going through here, the bottom part, and the current going through the top part. No, of course, we could find the current going through here and through here, which we would just break that current going through the bottom part into 2, so that's not terribly interesting. But let's find the current going through here. Let's call this I2, and let's call the current through here I1. So I2, current going through the top part, is see, it's just it obeys Ohm's law, so the voltage through the, right, go through the top part is one resistor, come around here, so the voltage across here must be V naught in magnitude, and so I2 would be V naught over R naught. And I1, the current going through here, would be, let's see, what's our voltage across here is V naught, and the resistance is this, 3R naught over 5, so we have V naught over 3R naught divided by 5, which brings the, that's the total resistance. We were doing the resistance here, which is 3R naught over 2, so 3R naught over 2, so that looks like that. So we have 2 V naught over 3R naught going through here, and that then breaks up into two parts here, and going through here we have 5 V naught over 3R naught. Of course, they have to add up to give us this, this plus this has to give us this, and that in fact, that's in fact the case. So V naught over R naught plus 2 V naught over 3 R naught is 5 V naught over 3 R naught. So that's compatible with that.